Hi ladies and gentlemen, this is Mr. Green and this is another in my lessons on Algebra 2. So what we're looking at today is polynomial remainder theorem. We're going to do some more synthetic division, some more dividing, and just letting you know how we're going to use that remainder and see what it does for us, okay? Don't forget due dates. I don't want anyone getting zeros on their grade book this semester. Okay, polynomial remainder theorem. You can use a polynomial remainder to help you find the value of a polynomial function. That's interesting. This is the way that the theorem is basically stated. It says, if polynomial p of x is divided by x minus a, the remainder is p of a. Well, we've already seen that. When we have roots, when we find solutions to something, we get a zero. Well, that's exactly what we were expecting to get. So when we take the dividend and we take the quotient times that divisor, we wind up with that remainder. So that's what we're going to be doing, is we're going to be doing just a little bit of synthetic division and a little bit of other division. As a matter of fact, we can do it both ways. Given this f of x, x to the fourth, x to the third, x squared, x minus 1, find f of minus 2. Well, how do we do that? I'm first of all going to do it with synthetic division, just because it is a little bit easier to do. So I'm going to say negative 2, and that's the one, negative 2, and that's the one that goes in the box there. Then I'm going to write the coefficients for the values. I've got x to the fourth, negative x to the third. I've got x squared. There's an x term missing, so I've got to put a 0 in there, and then a minus 1. And I'm going to take this minus 2 here as the number I'm going to try to divide into it. So let's start with this. We're going to bring down the 1 to begin with, multiply it times the minus 2. Add these two, get a minus 5. Multiply it times minus 2, we're going to get a 10. Add these two, 11. Multiply times negative 1, you get a negative 22. Add these two, you get a negative 22. Multiply times negative 2, you get a 44. Minus 1 is a 43. So I'm expecting that the value of this minus, when I stick the minus 2 in for x into the equation, I should get 43. Let's try this. So let's see here. We're going to have negative 2 to the fourth power minus 3 times negative 2 to the third power plus negative 2 x squared minus 1. Okay? Now, I've got a calculator here. So I'm going to take that and use it. It's nice to find a line in this part to most use of the lot when I use Mr. Jones. X to the third power and negative 2x squared minus 1. And what do I get when I do that? And I made a mistake. Okay, try it again on the calculator on the screen here. So hang on a second while I start up my calculator. Okay, let's try it again here. So I'm going to say parenthesis, negative 2, parenthesis, to the fourth power, move forward, minus 3 times, parenthesis, negative 2 to the third power, move forward, plus, parenthesis, negative 2 to the second power, forward, minus 1, hit enter, and I should get a, wow, that's nowhere near what I had before. Let's try that a different way. Okay, Tried it again, got it to work this time. I'm sorry. I put 4x to the fourth minus 3x cubed plus x squared minus 1. And what I'm going to do is I'm going to evaluate that for x2. So I'm going to look at the table of values here, and I'm going to look at -2, and I got a 43, which is the same number that we got right there, 43. So you can see how evaluating a function using division and evaluating a function this way works out to give you the same values. Okay? So it is one of those things where you can use that technique. So here we've got a polynomial. They want to graph it. Well, we need to find some points to graph it. One of the ways of doing that is using synthetic division. We're going to use the polynomial theorem to find the values that we could be using. Okay? So let's look here. We've got x squared, oops, I didn't want to write them as this. I want to write it as a synthetic division. Let's see here. Let's see here. Let's try this. So we've got what we're going to divide by. We've got an x squared, a minus 4, and then a minus 1. And we're going to start off looking at -1. So we put -1 in there, bring the 1 down. 1 times -1 is -1. Add those together, we get a -5. That gives me a 5 there. And so when 5 plus -1 gives me a 4. The value at -1 is 4. I stick a 0 in here. Okay? I'm going to actually do it this way. Put another line here, put 0. Put a line down here. Bring the 1 down, 1. 0 times 1 gives me 0. -4 plus 0 gives me a -4. Times 0 gives me a 0. 0 plus -1 gives me a -1. And so at 0, the value is at -1. So I do 1. Bring the 1 down. 1 times 1 is a 1. -4 plus 1 gives me a -3. Times 1 gives me a -3. Gives me a -4. -4. And if I put a 2 in here, bring the 1 down. 2 times 1 gives me a 2. 2 times -4 gives me a -2. 2 times 2 gives me a -4. Adding the -1, -4, get a -5. Can you see I'm getting points that I can now plot? I've got -1, 4, 0, -1, 1, -4, 2, -5. It just is giving me a series of points that I'm able to plot and get a graph. Okay? So let me go to a new page here and pull a piece of graph paper up. There we go. And let's go back and look at some of those points that we were looking at there. -1, 4. So that would be at -1, we go up to 4. It'd be plotted right there. And at 1, 4 was right there. And then we had 0 was at -1. And at 2, we were at -5. So 1 was at -4. 2 was at -5. Okay? Looking at this, we've got some points here that we're looking at. It's looking like it's doing that, doesn't it? So we need to find a few more points to be able to graph it completely. So if we do 3 in there, okay, oops, at 3, you get a 1. 3 times 1 is a 3. That gives you a -1. That gives you a -3, -4. So at 3, it's at -4. 4 gives you a 4, gives you a 0, gives you a 0, gives you a negative 1. So at 4, we're at negative 1. I think we found the vertex there, right? So we're at 3, we're at negative 4, and at 4, we're at negative 1. So at 3, we're at negative 4, and at 4, we're at negative 1. Like that. Okay? Let's do one more here. 5. 1 be 5. Be 1. Negative 4 plus 5 gives you a 1. 1 times 5 gives you a 5. 5 minus 1 gives you a 4. So at 5, we're at 4. That would put us right up here. And so we've graphed it using synthetic division to find those points. Cool? It is a cool way of doing things, okay? So, here's an application problem. It's a baseball being hit straight into the air, has an initial velocity of 20 meters per second, and a height after the ball after t seconds is modeled by the function negative 9.8 t squared, it's supposed to be a squared, plus 20t plus 1, where the h of t is the height in meters, neglecting air resistance, things like that. So they're asking, what's the height of the baseball after 1.5 seconds? We can use our synthetic division here, right? 1.5 is going to be divided into negative 9.8, 20, and 1. So, draw our line, negative 9.8. Negative 9.8 times 1.5. Boy, I don't have a clue. Clear. 9.8 times 1.5 gives me 14.7. So when I multiply these together, I get negative 14.7. Okay, so adding these together, I'm going to get a 3. 9 minus 4 is 5. 5.3. So I'm going to multiply 5.3 times 1.5. And I get 7.95. Add those together, I get 8.95. I'm saying that it'll be 8.95 using synthetic division. Using this method over here, negative 9.8 times 1.5 parentheses squared plus 20 times 1.5 parentheses plus 1 gives you a total of 8.95. We got the same answer going both directions. Now, do I care if you use the synthetic division or you use this method? They're both methods for finding solutions, for finding the value of an equation at a particular point. Okay? So, I appreciate you guys listening to me and letting me deal with these issues. And if you have any questions, feel free to give me a call. Send me an instant message. Send me a K-mail. Just make certain you always tell me that you're in Algebra 2 when you do so. Thank you very much. I'll talk to you next time.